Hi folks, in this video we're going to talk about the common concepts you need in order to understand the standard 3D material workflow. The terminology is common across all 3D software platforms, and in fact 3D software has now adopted some sort of visual nodal structure that works from left to right. Nodal workflows are extremely common concept for software applications, and you should get familiar with navigating these networks for a variety of functions. So let's take a look at a standard material setup. The most basic material setup simply has a shader node and occasionally an output node. There are typically different kinds of shaders depending on the software you are using and what you are trying to achieve, like glass or fog or emission. If your object has no discernible textures or patterns, this might be all the nodes you need in your material. But as soon as we want to mix patterns or textures in our surface, we need to plug in nodes that flow from the left side of the diagram into this shader and output onto the object. Most commonly to the left of the shader, you will have texture nodes that apply a pattern onto the surface. The most common is a bitmap node. This is a reference to a file on your hard drive that is an image file like a JPEG or a PNG file. Another type of texture is a procedural texture. This might be a gradient or a noise or a color, but these are generated by the 3D program and do not reference an image file in the directory. Typically, many of these bitmap and procedural textures are combined using a variety of mix or math or correction nodes and then piped into the shader. To the left of the texture nodes are usually the position, coordinates, or UV nodes. Sometimes these are separate nodes, and sometimes these are one node. These nodes tell the material you design further down the pipeline how to position it onto the object. Without these nodes, the program's not going to know how we want the pattern or texture to apply onto the surface. When we import our 3D mesh, sometimes it will come with what's referred to as a UV layout, which is a flattened version of the object. Just like XYZ axis in 3D space, U, V, and sometimes W are coordinates along a polygon's surface. Early computer programmers just assigned these letters. They're not an acronym for something. Sometimes a mesh is not UV'd at all. If the mesh does not come with a UV layout, you can use standard mapping to repeat and tile the texture over the object in different ways. We will talk about these modes in a separate video. In addition to the texture coordinate node, we can use a variety of other inputs. These allow us to pull more information about our model and affect how we apply a material to it. Maybe the position randomizes based on the object's name. These are great ways to apply textures to only certain named faces or vertex weights. The basic shader usually has inputs for metallic, roughness, anisotropic, alpha, etc., as well as others. As I mentioned earlier, there are also different types of shaders in the 3D program. A glass shader might be completely different than an ocean shader. 3D programs have different shader types for different purposes, and each has different inputs, but all of these come back together to an output that creates a material. So that's how mapping textures leads to shaders, which leads to materials for your object. Each 3D program varies a little bit in how it handles this, but there are remarkable similarities across all software, and even different renderers, which should allow you to move freely between programs. These material networks always look daunting when you first open them, but simply following the flow back from right to left, things become simple very quickly. This concept quickly becomes second nature for any 3D artist, and it opens up huge opportunities for you as a designer. Companies and clients are looking for artists who can quickly create unique materials and shader workflows for their designs. This was just an introduction to material nodes. You'll dive deeper into all of the options and effects that you can create in your future classes. All right, stay inspired, work well, and I'll see you next time.